Good morning, one and all. I welcome back to the model number 2. Mainly, in the previous sort of the module 1, you have come across regarding what are the terminologies that we have used in relationship with respect to the water or in particularly categorization of the wastewater. It may be in terms of refuse, sullage, sewage, sewerage, and then dry weather flow, wet weather flow, combined systems, and then separate systems and partially separate systems and all. So, these are the elementary things that you need to grasp the knowledge and to know the fundamental things. Whereas, in the model number 2, there are two critical categorization. The first part of the module 2, it mainly deals with respect to the designing of sievers, mainly designing of sievers. Whereas, the another part of the module 2, it mainly relates to the characterization and sampling. So, you come across sampling and then characterization. Finally, you go for studying all these things will be taken on the later part. But now, we shall take upon this topic related to the designing of sievers. I will introduce what are the contents are there for the designing of the sievers, and we shall discuss the topics as well as the subtopics in the upcoming series of the sessions in the model number 2. Now, here in the designing of the sievers, mainly where it is inculcated, whatever the designing considerations that we need to take across is mainly dependent upon the hydraulic conditions. What are those different hydraulic conditions? Mainly, first one is related with respect to the geometry of the or the shape of the sievers. Okay. So, designing of the sievers, they have certain considerations, like how you have come across in the case of the water treatment systems, we have certain things. But normally, how do you going to go for designing? Also, what are the sewer materials that are being used? Sewer materials that are being utilized has been explained by Sir itself only, where you come across the different type of the pipes also, maybe cast iron pipe, steel pipes. So, concrete pipes reinforcement has been done, and then asbestos cement pipe, plastic pipes and all. So, if you take the pipes as well as their materials which have been utilized for the construction activities and for laying of the sewer lines, the gradient as well as the sloping becomes very much important. Now, let us get to know what are the contents that you go for studying in the module number 2, especially the first part is designing of the sievers. In the designing of the sievers, you come across for learning the concept of how and why the designing is an important aspect, that we call it as a designing considerations. And you, before knowing the designing considerations, you need to come across the fundamental principles or the scientific aspects why we need to go for the alignment of the sievers. Okay, first one is mainly related based upon the considerations of the fundamental principles. And then you come across for various hydraulic formulas. So, these hydraulic formulas mainly comprises of utilization of the different coefficients, maybe the usage of the continuity equations Q is equal to AV, it is also suitable here. So, the driving mechanisms differences everything that you need to go through it, because you have to apply all those concepts. Then hydraulic formulas are there, and then design considerations. So, for this hydraulic formulas as well as design considerations, you have certain terminologies that you need to come across for it, and finally you need to go for design the different geometrical sievers. Okay. So, these are the 4 fingerfold aspects that we come across in the designing part of the sievers. So, terms are simple, but it is wider to know. Now, in today's part of the class, I will go for explaining the fundamental principles part 1, because it is not complete. You need to go through across the certain different parts, then only we can come across for the different parts of the hydraulic formulas which are being utilized for the design considerations. See, in the water supply and treatment, there are 2 important aspects. So, the differences that you can go for seeing it. What is the major thing is, whatever the water which is taken up from the river or maybe a sources, it has generated and it is taken through the screens, allowed through the pumping stations, and finally treatment, distribution system. From the distribution system, it is mainly leading to the homes or maybe for a particular layout. That is a one critical aspect. Whereas for the sievers and all, where the wastewater is to be collected, for the collection it has to be done from the point of origin to the point of the disposal. So, this design of the sievers mainly go for providing a boundary, or maybe we call it as a closed system. We also have 2 types, what we call it as a closed system as well as even an open type of the system. What is meant by closed type of the system? Closed type of the system means they are particularly either rectangular across even the different types of the sievers, egg shaped sievers, circular type of sievers, rectangular or maybe trapezoidal type. So, open system mainly consists of like a storm water drains which are either rectangular in nature or maybe trapezoidal in nature. So, these are the 2 type of the systems that we go for seeing. Only thing it is, sometimes they have the covering, sometimes they do not have covering, openly exposed to the atmosphere. This is the one sort of the things where they go for the combined part of the system. That is the worst part. Not I can say that completely a worst part, but in nowadays it is better to adopt for the separate type of the system itself only rather than the combined, where we cannot go for having the proper control measures. Closed system can also be rectangular, circular or maybe elliptical in nature. Okay. So, these are the type of the systems that we go through it. Mainly for an engineer, if you go for taking any of the designing aspects, first and the foremost things comes to design with respect to the geometrical shape, that is the one thing. Considering the various factors which have been affecting it, that is the second part. Third thing, it is designing with respect to the flow conditions. The flow conditions, how they are in flow as well as the outflow, whether they are laminar in nature or turbulent in nature. We have either a greater velocity of the flow or lower velocity of the flow. All these factors has led to know the designing portions in understanding the fundamental principles. If you understand the fundamental principles, you can go for listing out the hydraulic formulas. Mainly they are empirical in nature. One more thing, the term empirical, it refers to experimentally designed as well as verified type of the value which is suitable for the designing for a large scale purpose. That kind of the formulas has been imparted in the hydraulic formulas. Next thing it is, for the design considerations, there are lots of things to be taken for an account. What are those? Let us get to know in the upcoming part of the classes. Now, with this, let me go for having the introduction part. Fundamental things is the difference between the water as well as the wastewater. So, wastewater, or what we call it as a siever, it has to be collected as well as it has to be conveyed to the point of the outfall, or what we call it as a disposal. This disposal conditions, we'll take it in the later words. Only till outfall we have. There are different types of the systems which are being adopted for here. The systems of the collection. We have laterals which are being originating. Finally, from the laterals we have submains. Again, from the submains we have mains, and therefore we have a outfall siever. This outfall siever means, for example, if you consider a home or a region or any other area, there are lots of houses. From each houses, the wastewater has been originated. This we call it as the laterals. Okay. Next, all these laterals, they have to be in line or in par arranged, and it has to be laid. Observe it clearly here. It has to be laid, and this part where it has been originating, okay, finally leading to the critical aspect, we call it as the laterals, or maybe we call it as a submains here. And then finally, if a main road is being coming for this, or maybe any of the roads and all, here also you have parallelly. So submains and then mains you have, or maybe we also call it as in another portion as a truncated type of the siever lines. Everything it is being running across for the roads, and this kind of the line which is being designated, it is for the siever lines. So from each and every road it is being taken up, therefore the velocity tends to vary, isn't it? When the velocity tends to vary, it has to reach through the mains, we call it as a main siever system, and then finally these mains may tend to go across an portion where we go for a system whether the treatment has to be given or not. That kind we call it as a siever outfall. Siever outfall. Now, if we need to take it for a siever outfall, what are the basic things to be considered? There is a major difference between the water as well as the wastewater. First point to be remembered here, it is systems of the collection may be open type means like this, closed type means circular or maybe X-shaped type of the sewer systems they have been utilized. I hope so you people might have come across the diagrammatic representation as well as even to know the virtual aspects of the type or the shapes of the sievers in the model number 1. Now, if it has to be aligned in a proper manner, as we have to take different decision making process. Why? What is the reason here? Conveyance means you cannot go for pumping from one portion of the area to another portion of the area. Mainly the laying of the sievers or the conveyance, they have to be made along with respect to in a gravity flow condition. Gravity flow condition, and the gradient which they go for laying it, it has to be always in the downward gradient. It has to be in a downward gradient. Why it has to be in a downward gradient? Why not upward gradient and all? There is a differences. What are those? Let us get to know. Differences between the water as well as the wastewater in the pipelines. If you take in the case of the water, solid particles or any other things and all, they are completely free from it. So, free from solid particles. Here, it is whatever the water is being utilized by the houses, when it is being generated, obviously certain type of the solids are getting mixed into it, water. So, in that it is have to be conveyed. Therefore, the lots of suspended as well as we have an settling impurities, or we call it as a solids, they are being present in nature. So, if they are present in nature, what happens? The deposition takes place, leads to the deposition. In the case of the water, there is no sorts of an deposition, means it will be only quite minimum or maybe negligence, we can say, if even though if there is a presence of a solid, during maybe the rainy seasons and all, you can see that the water is turbid in nature, okay, in that regard. They have been pumped from the distribution mains itself only. So, minimum deposition, so therefore that is not at all a problem. Here if the deposition is being to a maximum extent, so therefore mainly a flow condition has to be provided so that whatever the gradient that you are going to place it here, okay, the downward gradient, so that it has to provide the silting of the materials not to deposit. So, it should provide the free flow condition, even these all material to be carried from one portion or a one point to another point. Okay, that kind of the velocity we call it as a self-cleansing velocity. We'll come back to that. So, understand the basic things. And next, here particle is a one sort of a consideration. The second consideration is it is the pressure. Pressure is where you can go for the pumping and the distribution or maybe in the treatment plants and all, you have it. Even though in the wastewater treatment plant also we have for it. But for each and every communities, do we need to adopt the pumping stations? No. Because the lines or the pressure for the water networks, they can be carried from a region of a lower elevation to a region of higher elevation and vice versa for it. Okay, vice versa is possible for it. Whereas in the case of the wastewater, conveyance has to be done in the downward gradient. That means region of hilly area or maybe higher elevation towards the lower elevation. That is the proper planning to be made depending upon which conditions, depending upon the topographical conditions. Topographical conditions, the ground conditions, and therefore the ground level, and even you also have the soil conditions. You should have to know the soil conditions also. Therefore, the pressure which is being generated here, whatever, so it is utilized only for the distribution purpose. What about in the case of the wastewater which is generated? It contains huge amount of this particle, so therefore it cannot be pumped out. It is only pumped when it reaches to the point of a outfall. So separate provision or the equalization tank will be provided. From there the sievers system where the wastewater is being reaching to the last portion or the last point, and there it is being lifted up by the pumps. We call it as a preliminary source of treatment which is provided. So these are the particular fundamental principles that you need to come across for it. Next important thing that we need to come across is related to the type of the impurities we have come across, but how to design it in a geometrical manner. How to design by considering the hydraulic coefficients. All those things, they come under the critical part of a category. Okay. So I hope so you people have understood the concepts related to the fundamental principles, how it has to be collected, which type of the sewer systems they are being provided, and then conveyance is the major part because flow conditions, it is under the gravity, not under the pumped flow. So if a new layout has to be planned, then also care to be taken where you provide the gradient in a proper manner, because you people are going for maybe extensive survey camp. There you have one project, water supply and sanitary project. For the water supply and sanitary project, you need to provide especially the downward gradient, maybe the steeper type of the slope also to be provided. So in that regard, it has to move from the lower elevation, and the treatment plant has to be present at the lower elevation, treat it, and then it has to be disposed or reutilized. Getting clear with this point? Now, after knowing the basic differences, maybe the particles in the water as well as the wastewater, you have a certain differences, and then pressure. Here it has to be a completely a gravity flow based, only in the lifting point you have it. These are the two major differences that you are going to see, as well as clogging of the pipes is one of the major problems. Clogging, why, what it is? Whenever during the function or the festival time, if you have the huge number of the waters to be utilized, maybe in a area and all, what happens? If the solid generation or the deposition is being more, it tends to clog the sewer pipelines. Or what happens? The settlement takes place. Whenever the settlement takes place across these systems, what happens? The flow velocity tends to decrease. When the flow velocity tends to decrease, so therefore there is a larger area for the deposition of the particles, thereby leading it into the formation of the deposition. We call it as a silting of the materials. We call it as a silting of the materials. In order to see that the silting of the materials to be made or to be carried away so that the deposition shall not tend to happen, that minimum velocity has to be provided. The velocity, the minimum velocity provided in the sewer pipelines in such a manner that whatever the suspended particles, if they are being tend to deposit, or higher specific gravity, if they are tending to settle at the sewer pipelines and all, they are also being carried away. That kind of the velocity, we call it as a self-cleansing velocity. Self-cleansing velocity. Why it has to be provided? Because velocity mainly refers with respect to what is the distance with respect to the time taken. It is expressed in terms of meters per second. In other words, there is also a velocity, we call it as scoring as well as non-scoring velocities. So what is meant by the scoring velocity? Score means the surface of the materials of the pipelines, it matters much, and the roughness content is also a major part. Thereby, when we come across the differentiation with respect to the water as well as the wastewater, these are the issues that we have find out. In order to see that the issues are to be minimized, which kind of the sewer system to be placed up. So therefore, we come across a separate sewer system. So therefore, a separate sewer system is better in order to see that the clogging or any other things can be minimized. We have certain things, laying, testing of the sewer lines, laying and testing of the pipelines and all. If any blockages are there, huge amount of the sewers containing larger part of the solid content or maybe any debris or putrescible organic matter which are being present, there itself only they have to be removed. Otherwise, the flow is not uniform in nature. Therefore, it may have two types of the velocity. One, it is a higher velocity, another it is a lower velocity. Lower velocity means settlement takes place. Higher velocity means scoring. Scoring means what? Abrasion on the surface of the material. That means inner surface of the sewer material. What happens? These solid particles may be grit or maybe any sand materials or that fragmented part of the fixtures. What happens? They tend to rub on the surface of the sewer lines. It is like cleaning. If you take any wood or any other things and all, and if you take some portion of any material, say for example, I have taken a plastic pipeline. If I continuously rub with the pebbles or any other things and all, what happens? The surface gets scratched off. And thereby, what happens? The scoring will extend. So therefore, the surface layer is wear and tear or abrasion taking place. This wear and tear has to be minimized. Upon the minimization, we need to have the optimum designing velocity consideration. So therefore, it has to be maintained that greater than the minimum velocity and less than maximum velocity. So therefore, we call it as less velocity means the maximum rate or maybe the velocity at which the scoring or the maximum velocity at which the scoring action does not takes place, we call it as non-scoring velocity. Self-cleansing velocity is mainly related to the minimum velocity of the flow condition. Whereas in the case of the non-scoring, it is with respect to the maximum flow conditions. So again in the flow conditions we have certain designing considerations I'll going for explain in the next part. Hope so. I think you have come across all these considerations. Therefore, what should be the diameter of the siever if you are laying a circular type of the siever, and do you have any sorts of an characteristics curves and all? If so, what kind of the ratios they have been developed? Welcome back to the session 2 of module 2. It is mainly related to the hydraulic design of sievers. In the last class, I think I have explained the concepts which are to be utilized for knowing the essentialities of the hydraulic designing aspect, or what we call it as a criteria, either the difference between the piped water supply system as well as the conveyance of the wastewater system, type of the sievers and their conveyance, and finally to the outfall. And we have also discussed related to the self cleansing velocity, that is the minimum velocity required for the movement of all those materials which avoids or which tends to settle at the bottom of the pipelines while providing the proper gradient. And we also discussed what is meant by the non-scoring velocity, that is mainly related to the maximum velocity of the flow where the wear and tear shall not tend to cease in nature. That we call it as a non-scoring type of the velocity. Now, let us get to know what are the different formulas which are generally used for the designing of the sievers. Maybe in the case of the usage of the formulas, it is related to the usage either in the US or in England or in sometimes in the Germany also, and in India we are going to use some sort of the formulas. What are those? Let us get to know one by one. First one, we have the Chasis formula. First one, we have Chasis formula. Chasis formula is mainly related to the velocity determination, where V is equal to C into root of R into S, where the C, it represents the Chasis coefficient. C is equal to Chasis coefficient. S or R is nothing but it is the wetted perimeter, that is equal to A by P. So it is represented in terms of in meters. We call it as hydraulic mean depth. Finally, we also have the formula. What is that? S is equal to nothing but the slope, or we also call it as the gradient. Slope or the gradient. This is the one sort of the formula. I think you have come across this kind of the formula in the designing of the channels also. Okay, in your hydraulics you have come across the formula. Similarly, here also it will be utilized. And to determine the value of the C, there are different sorts of the formulas. What are those? Let us get to know. So for this determination, C has a sub kind of the formula. We call it as a Cutter's formula. To determine the C, we have the Cutter's formula, where C is being given as an empirical equation which has been experimentally verified and the relationship has been established. That is the one kind of an equation. We have 23 plus 0.00. Be careful for here. So 23 plus 0.00, 5, okay, 5, another decimal, 155, and you have the slope. This is one condition, and the numerator multiply by one factor, okay, plus 1 by n divided by, next you have another same, that is 1 plus 23 plus 0.0155 whole thing that we have here, this divided by s, plus we have another formula, but instead in of 1 by n, we have a multiplicable factor that is n divided by r, that r to the power of 1 by 2 or square root of r. This is a formula for the determining the Kutas equation where the Chasis coefficient can also be determined. Another formula we call it as a Hazen's formula. What are those? Let us get to know one by one. So, Hazen's formula. The Hazen formula is also being given with respect to the determination of the Chasis coefficient itself only. So, this kind of the formula is normally utilized even in the UK also, and let us get to know the formula 157.60 divided by 1.81 plus h divided by square root of r, we call it as a k divided by square root of r, where k is called as constant depending upon the inner surface of the material, constant on inner surface of material. Inner surface of material. What about here the n? We call it as a roughness coefficient. This Chasis coefficient can also be determined as roughness coefficient depending upon the surface. Okay, so these are the two formulas. Next, another set of the equations where we go for calculating the velocity. It is given by the Manning's formula. We have a Manning's formula where the velocity is being given as 1 by n r to the power of 2 by 3 and s to the power of 1 by 2. Again, we call it as n can also be taken as a small or maybe capital also. In some of the textbook they go for mention, where n we call it as the Manning's roughness coefficient r is nothing but a divided by p. We call it as a wetted perimeter. P is the wetted perimeter and this is the hydraulic mean depth. And then S is nothing but we also call it as a slope or maybe in terms of an gradient also. Okay. So, these are the certain set of the formulas we generally go for using it. And meanwhile, we also have the Krim's and Berg's formula. Okay, Krim's and Berg's formula, third one. Krim's and Berg's formula. This formula is mainly related for the calculation, where instead of that 1 by n, we have a factor for this. We have a multiplicable factor. What does that mean, multiplicable factor? We have 83.5 r to the power of 2 by 3 s to the power of 1 by 2. So, V is equal to 83.5 r to the power of 2 by 3 s to the power of 1 by 2. Same thing, hydraulic mean depth. Yes, and 83.5 is what we call it as a roughness coefficient value taken for the empirical factors. Next, we also have the formula where instead of comparing for this, if you take 83.5 is equal to 1 by n, which implies that n is equal to, okay, you take the reciprocal, is equal to 1 divided by 83.5, which gives you 0.012. So, that is the factor where we have taken it, 1 by n is equal to. Okay. So the modified form of the Manning's equation is also utilized in the form of the Crimson-Berg's equation. See, whatever in the case of any development of the engineering aspects or maybe any of the mathematical principles applied there, there will be certain modifications. We call it as a modified equations. We have Hazen-Williams equation also, and we also have other set of an equation, we call it as a modified Hazen-Williams formulas. This kind of the modification is mainly made according to the experimental results they have obtained and they have verified in an empirical manner. That is why this values keeps on changing from one to another. It does not remain the same based upon what kind of the relationship they have established. So with this, I think Chasis formula for determination of C, we have the Kutter's as well as the Bessen's formula. Especially for the Manning's formula, we have V is equal to 1 by n r to the power of 2 by 3 s to the power of 1 by 2. Same thing, it is also applicable here. Now, next set of an equation that we come across, it is Hazen-Williams formula, where we have, I am going to rub this apart. Hazen-Williams formula, this Hazen-Williams formula is also utilized for determining or calculating the velocity. V is equal to what? It is 0.85 C suffix h, Hazen-Williams coefficient, okay, r to the power of 0.63 and s to the power of 0.54, s to the power of 0.54. So this is the same modified part of the Manning's equation. See, the r and s remains the same, but the coefficient values tends to change up here. Okay, this formula we call it as the Hazen-Williams coefficient, where the determination of the CH can be determined based upon the type of the material or the roughness of the pipe material. So therefore it is different, like in 120 or 130 the value will be for that, and so on for the different asbestos cement pipe or maybe RCC type, or even if you are going to take the cast iron pipe, plastic pipes, everything it will be different in nature. So the roughness will be major in the case of any one of the concrete or any other things and all. But what happens, the wear and tear is also more. So therefore they go for using the vitrified portion in that the bottom portion, especially for the pipes, in order to see that during the non-scoring also what happens in the maximum velocity cases, the abrasion which is being caused should be minimal in nature. If you take in the case of the plastic pipes and all, I think sir has also discussed in the previous part on sewer materials and all. There the plastic pipe, if you are going to take, the surface is quite smooth in nature, therefore the velocity of flow can also be established in the maximum rate, and that is the reason where we come across for fixing up of the values either for the minimum as well as the maximum velocity. Now we shall continue back in the next part of the session. Thank you one and all.